Hey everyone, welcome. I hope the correct screen is visible, which reads tidier.
Yes, it is.
Okay, yeah. Okay, again, welcome everyone for almost first discussion of our group. So I thought it's a good opportunity to kind of present about my package. It's called tidier, and I'll kind of explain what motivated me to write it and what this does fundamentally, how it can help us, right? And also we'll spend last few minutes discussing about how to, essentially write a package, also put it on CRAN and other things if anybody has questions on that, right? So we ideally want to build a community and also help each other out in that activity. So essentially that is my primary motivation to present here. So starting off on that note, right? So let's first spend some time to understand what the package does. I'll give a presentation on that. So this is tidier. It's more of a play on the word of tidier, TID, the package probably most of you are familiar with, which kind of gives you utilities to widen the data frame and pivot the data frame, all that. Anyway, so basically in my work, I used Apache Spark, and Apache Spark provides some very nice functionality to window level aggregations. Right. So these window level aggregations have been there from good long time and it's been a common staple thing for most databases. Right. So we'll spend 2 minutes to understand what this window level operation is so that it gives us a good motivation. Right. So here is a picture of a data frame, let's say, or a table. So let's say you're at a current row and you want to do some sort of an aggregation. And for that aggregation, you want to consider some number of rows behind you and some number of rows after you, right? After the current row. So you want to utilize this and probably do some aggregation. Let's say you want to say average, right? Guys, can you go on mute? Who is talking? So you can actually precede some rows and go ahead in some rows in front of it. This is the generic form. Indeed, it is also possible to not include that row also. I'll give one of the examples which I think a lot of times we all utilize in data preparation. So you want to understand, let's say, for a particular thing, for a particular row, let's say it identifies an item. You want to know how many items got sold in last week. So you basically want to precede and not include that row itself. So we can always do that kind of, let's say, feature creation or new variable creation. And that is really helpful in a lot of statistical and ML models. So that was how I kind of started out and then asked this question, whether can I do that in for our data frames, right? And really struggle to find anything. There are 1 or 2 utilities, but most of them are very slow or not something that is tidy, right? So one of the very nice things that was written, which has that capability and which tidier package actually stands on, is this very nice utility called slider. And no surprise, slider basically comes from one of the employees of POSIT. It's Davis one, right? And this is written very fast in C++. So you can do rolling window kind of operations on any R data type, as they say, right? And one of the things that it supports is a data frame. But this is written in its own syntax, so I thought, why not package this and write it in a way so that it's intuitive for a tidyverse user. Right? So that is where tidier was born. And that's the main showcase of this. So once that is done, a few months back, I decided why not also have a similar syntax to work across databases, right? So then I kind of extended that to dbplyr remote tables, right? So that's where we stand here. So I'm going to take the users through both of this experience and let's see how this works, right? So here's the README. There's no winnet here. This is a README that should kind of tell us most of the things. Right. So I'll straight away move to the example. Kind of, it has things with all the complexity of all possible generic complexity, but it's a single example so that it gives us an intuitive feel. So I picked up one of the inbuilt R datasets, which is air quality, right? And it actually has columns like month, day, and all that. So we made a date column out of it here, right, through a mutate. And then after this, I'm creating gaps by removing some days. This is to kind of show that when you want to move up and down in that frame, right, corresponding to a given row, you can do that even if there is gap in time. And this is one of the most important functionalities of what we want to build. So here we go. So I'm actually sampling this, which means some days will get removed. So once that is done, so here is the mutate, right? So here is the holy grail or the very main part of this package. So tidier package exports the mutate function. Now, people might be thinking, should it be a S3 generic? For some reasons, it's not S3 generic, it is just a function, right? So usually encourage the users not even to load the tidier package, directly call it whenever you need it via namespace, right? So let's see what we do inside, right? So it's your familiar mutate. So as soon as you see it, you know that once you operate, you're going to get a new column, right? So here it is. So all we are doing is taking average temperature over the last week. Now here is a question, right? So how do you want to specify this? The first thing is you have to make sure that your data frame should be ordered by day, correct? And it should be grouped by month. So these two specifications, order by day and group by month. So newer versions of mutate from dplyr already give you dot by month. So what we are doing is we are overloading this with more other stuff. Essentially, tidier mutate gives you all those functionalities in one loop. So you have order by and you have whatever you're grouping by. Right? Once you have these two things, now you need to decide how many steps you want to go back. Right? So that's where frame comes in. So the first argument of frame basically tells you how much you want to go back. Right? So here we want to basically move over a particular date column. That's what index says. So all your frame should be with respect to this index. Now let's say all you want to do is go some number of rows behind, then you don't even need to specify this. So index does not get specified. And whatever you write here, let's say instead of liberate day 7, if you write 3, then you're telling that I want to go 3 days back. See 3 rows back to be precise. But here we're talking about a date column. So we are specifying an interval object. And that basically tells I want to go 7 days back. And it also says that I do not want to use the same date. So I want to do everything before that. Right? So I'll go back to this picture now so that our idea is complete. So all we're trying to say is go 7 days backwards and not include this row. So people who have seen this or written this code in SQL, it's kind of stable, not anything complex at all. So I'll also show this example, how this gets written in SQL. Right? So here we go. So let's see what they are doing in this case. So if you see, so the ordering by months, this is month-on-month data. And they're actually going 1 row behind and 1 row after. So this is a different aggregation. It's a moving average aggregation. What we are doing is that we are telling that tidier syntax gives you an ability to do moving averages or however you want to do it around it. So it's a generic tool. So once you specify run a mutate, you can close your eyes. This is your regular mutate. It's going to give you the new column, right? And you can see that in action. So this is it. This is as simple as it can get. So what I'll do is I'll run pretty much the same example and show that it runs. Right. I'll come to more. So here I had prepared an example for running this on a database. And I'm going to show that next. Right. So I'm going to run this. Right. So this is your air quality database dataset. Simple data frame with 153 rows. Right. Let's see the head. So you have ozone, solar, wind, all of that. Temperature measured across a particular month and a particular day of 1973. Okay, so what I did, as I explained, so created these columns, I'm taking the sample. So let's see what happens when we do these things. So you get this data frame, nothing special except a new column has gotten added. Okay. So now time to run this tidier mutate. Let's see what we get up with. So you see, rather the table output simply says this, right? So every date call column, if you see, we went 7 days back and we computed the mean. So of course, wherever we cannot compute the mean, you're getting a missing value, but otherwise you always get a value that's present. Right? So what I'll do right now is also compute something else. Here, show a more easier case. Let's say you don't want to really work with index. You really don't want to go back on date. Is there a different thing that I can do? Can I go back a few rows, let's say? So what I'm going to do this time is I'm going to specify frame, but this time I make it very simple. Go back a few rows, right? So let's say I'm aggregating temperature. I want to simply go 5 days back, right? And I do not want to use that day also. So I'm going to go one step to the left. So here we go. So this is a different computation, but here you are operating on number of rows. You're not operating on number of days, right? So if you have to operate a number of days or any object that has an interval, right? So then you have to actually specify which column that you're utilizing. Right? So all of this is powered, as I said before, by slider, and slider does most of the heavy lifting. Right? So that's beautiful. So what really happening under this is a lot of C++ nice code, which is written, and that's kind of pretty much what we utilize. Right? So before we kind of go on to the package writing and other things, I'll specify, I want to show what happens on the database. Right? So what I'm going to do here is, I'm going to actually open a data set, all right? And then I want to connect it to maybe SQLite database or DuckDB or one of these things. Just want to show everyone how it works, okay? So let me do one thing. So let me open a smaller data set. Although I'm not going to run this, I just don't want it to spill over and let other things happen. Okay, so I have some database here. Let me do one thing. Let me connect to this. That will be better. So I'm loading DuckDB also. Okay, here we go. All right, so I have one table. That should be good enough for us to see. All right, so this is the famous Avazu's data, which is the click stream data, the click data. Right, so if you guys have seen this before, let me use this once. So basically every row records whether a click was done or not, 0-1 signal that you see here. And a lot of metadata was given. So this was one of the earliest competitions where people worked on clipstream things. Anyways, it was like pretty big enough for me to kind of pick that here. Right? Sure. So with this, let's do something interesting. I want to create a feature using tidier mutate. So now one of the nice things with tidier mutate is your syntax or other things don't really change. All you need to do is you just need to operate on the same thing. All right. So let's say you're basically trying to create a feature. I'm trying to create something very simple. Let's say, so you have a device ID, right? So let me not do that. Let me take a device type or something. Yeah, here it is. So there's a device type. So there will be different device types. So by device types, I just want to understand what is happening to the number of clicks, right? And I want to understand what is happening in time, right? So I'll pick also some variable. Let's say R and order by that, okay? So average clicks. So I'm taking the average of click. And let's order by, I'm just going to want to bring every complexity. I'm not going to run this. I'm just going to see, I'm just going to show everyone what kind of SQL gets generated underneath. So by, let's simply group by something. I mean, none of these have any significance per se to the problem right now that we're trying to solve. It's just that we need to solve this to show, okay, let's say device type. So let's say order by R. R is another variable, the third one, right? So all right, fair enough. So that lets me specify a frame. So I'm simply going to specify go all, let's say, infinitely many rows backwards, starting from the inception of time, and don't use that row. So now let's see what SQL this gives us. So there's a dbplayer function. It's called SQL render. It's going to tell us what SQL will be run if we actually run this. So here we go. So if you see this is what we are actually doing. So we are actually telling calculate the average value of click, right, over a particular partition by device type, and you order by R, and this physical that gets generated. Rows between unbounded 1, preceding and 1. So one thing that dbplayer doesn't support at this moment is creating that index variable and then moving along it. All that is currently supported is number of rows on either sides on the database backend, right? And that is what we promptly support. But there we go. I don't know how much long time this takes to run. This is a different one. I'm just going to let it run. Right. So this is it. This is pretty much all I wanted to speak about tidier. Right. So I'll spend maybe 2-3 minutes talking about the package, how it was done, how it was developed, and anybody wants to know anything about package development, I'll spend some time. So here is the package on GitHub. Right. So I think it was 5 months back when I first put it on CRAN, and another release was done recently where the database thing was there. So it's easier to showcase this package because there are not many functionalities into it. It's just one core functionality which is simply muted. Right. So let me directly jump into the R package. Right. It's where all the R code is supposed to be, and this one just one single muted function. So also there's a helper called mutate underscore for people who want to use string-like arguments, right, and not really dabble with Erlang's way of converting things to symbolic notation. So anyways, I'll quickly move on to mutate function. So we both are almost similar copies of each other. So here is mutate, the one that was just now showcased. Right. So everybody's familiar with these arguments that we just now kind of saw. So here's the code. Right. So this is just to illustrate. I'm not going to go through different lines of code and all that. I'm just going to show everyone that how things are written. Right. So we have two different things, right? One is for data frame, the other is a lazy table. So for both of the things, we will actually run this and show. We're writing different code. Right? So a lot of cases have to be handled where order by could not be there, by could not be there, frame could not be there, all of that. So all of that is, if you can see, will be handled, right, at different points of time. And we are also capturing the arguments, like because we are writing the things unquoted, so all of them have to be captured. So we have done that. So once all of that is captured, so I'm moving down to coming to the main part of the logic. Right? So here is where the slider gets used. So this is a very simple thing. You don't have any groups, right? The by is missing. So you're going to slide through the entire data frame per se. So if you see what's happening, the core of the operation is this. So you slide through every row, and in every row, you basically say that whatever is that the chunk of data frame I get, you need to give me one summarizing thing. You might wonder for a minute that isn't this mutate, but you are now operating at a row level. And row level, operation is a summarize because you want to get one row as an output ultimately. Right. So this is done. We kind of do some nesting wider because it's possible that what you get is a complicated object. Right. So this does all the things for you underneath it. As a user, you don't have to ever worry about this at all. But just for anybody who wants to understand it, you just don't have only users, you also have developers here and people who are keen to understand how this works. So I would say, if you're interested, please go through this. If you think this can be made better and want to contribute, everybody's welcome. So this is built by us to the community, and we definitely want that feedback, things to go from there. All right, so I'll quickly move to the data base part of it, okay? So which got recently added. So this is various cases handled for the databases. And so here we go. So the code is pretty simple from the database part because most of the call is from dbplayer, right? So dbplayer, if you don't have any of the groups, it's very simple. Right? So you first create a group by object or not, depending on if you have by or not. Then you define a window frame. So window frame gets defined this way. So once the window frame is decided, you also can specify an order. So that gets defined here. So once the window order is defined, all you need to do is simply run your mutate operation after that and ungroup for the safety of it so that the grouping doesn't remain for the user later. So this is it. So this is as simple as it goes from the database end, because all heavy lifting is done by DB at this moment. So this is it. So code is simple, pretty much. There are a few helpers, one or two helpers I wrote, and writing some very careful tests. I think this is an important part in having user confidence that this is usable. From personal end, we've kind of used it at Walmart to write one or two bits of production code also. It's been running like a charm, right, over BigQuery and other database backends. So a lot of testing is done like very carefully, like where various group by is missing, right? If that happens, does it still run? So very, very careful testing is done over data frames. And there is also a test where we are testing whether database version and the data frame version are giving the same answers. Okay. So that is also done. So that's done here actually, if you see. So converting that to an in-memory data frame and testing this. If you guys have any other interesting ways of testing this or more complicated tests, we'll be really happy to include that. So here we are. So this is tidier. I think also spoke about slider on the way, and DB player is ubiquitous. It's there everywhere. Without that, you cannot get this up and running. Okay. So let me take this to slider readme. Okay. And another thing that has really made it win is DB player, which extends this to databases. So here we are. So it's a wrapper package to do something familiar and gets your job done very quickly, and you don't have really headache of thinking through complicated window operations. So guys, that's it from my side. I'll be happy to take questions.
Thank you, Srikanth, for such a lovely informative session. Really loved it. I had one question though, in terms of code. So from what I understand, you are capturing as an expression, and then are you returning the expressions in the code, or are you also evaluating it? Because I understood
I'm not evaluating that. I'm just passing it over to the required deployer functions.
Right.
Okay. So for example, here is NEXPR from our line, right? So for buy,
right,
for example. So that buy will simply be used further. Mm-hmm. So I tell you, this buy goes and gets utilized inside deployer's buy.
Right. Essentially, all the attributes that are present for the mutate function, we read that if they are they have been provided. If yes, then we call the underlying packages, load them as an expression, and then create the output for it to work in the pipe operations.
Yeah.
That's brilliant, man.
Yeah. Yeah, they get passed. I mean, as a user, you don't not notice anything. It's just the usual thing, right? So I think this is where the example becomes most important. You see these examples across stuff. So this is pretty much what most our users have to write.
Right.
That is there. So the reason for creating mutate underscore was also to kind of help users who are actually getting that string from outside. Let's say the function. Of course, you can do that transfer again using Rlang, but it's better, right? I'll show an example how some set of users might want to use this. For example, this. If you have this, let's say, in a character vector, it's coming to the input of the function. You can still write this order by, but there's no way to actually write this expression, of course, right? So the syntax has to be still written. Right. Order by and by is something that we will take. If you use mutate underscore, it's simply a copy of mutate.
Right. So I'm just thinking in terms of documentation. I might be wrong, but it might be helpful to have the code that you would have used to write if you didn't write this, to show the advantage of using it. Just thinking out loud, basically, because you have done all this heavy lifting, right? Let's say I didn't use tidier, and as a normal user, I would want to implement window functions in my workflow. So then you have to obviously use 4 or 5 packages, and then you have to know all all
Right,
the
right. Correct.
correct functions to use and how to use. So I think having one example to showcase the difference and the easiness of these functions would be great.
Yeah,
From
that's
you.
a suggestion. Yeah, that's a good suggestion. I'll see if I can bring some code from here, right? Showcase that. For example, anybody wants to see this, things pretty much shows this thing also.
Right.
So somebody here is an example over cars, sliding over that where you get data frame in pieces.
Right.
You have to do your separate, let's say you have to apply map or lapply, get pieces.
There could
Then
be
again,
4 or 5 more steps, but then it will just show portray the strength of the package. Is what I'm thinking.
yeah, agreed. Yeah, sure. That's a good idea.
But thank you so much for presenting this. It's definitely has been a lot of learning for me personally. So yeah.
Sure. Thanks a lot.